Ladies and gentlemen, the second invited presentation will be delivered by Dr. Wenyan Han, Tea Research Institute, Chinese Academy of Agricultural Sciences. We cordially invite Professor Janaki Mohoti to chair the session. Over to you, madam.
Thank you, Ravani. Good afternoon, ladies and gentlemen. I warmly welcome all of you to this session. It gives me great honor and privilege to introduce our invited speaker of this session, Professor Wenyan Han. Let me briefly introduce Professor Han. Currently, Professor Han serves as a professor of tea science and chief scientist of tea cultivation science and technology innovation team of the Tea Research Institute, Chinese Academy of Agricultural Sciences. He's a globally renowned scientist, especially when it comes to tea, organic agriculture, and climate change. This talk also comes at a very appropriate time as we feel the importance of tea to Sri Lanka as an income generating crop as never before and experiencing the effects of climate change. Let me very briefly introduce Professor Han. Professor Han possesses 3 Bachelors of Science degrees from Hangzhou Agricultural School and Zhejiang University of China. He earned his master's and the PhD from Zhejiang University of China. He is an expert in organic agriculture, and he has also obtained many professional international trainings. He's trained at Organic Malaysia Alliance GrowLink in Malaysia, FAO and Chinese Academy of Agricultural Sciences in Beijing, GreenNet and GrowLink AB in Bangkok, United Nations Institute for Training and Research, and Soil Science Certification in Bristol, UK. And he also serves as an International Organic Agricultural Inspector since 1995. He has also served in many national and international expert committees, and currently he is a member of the panel of experts of the FAO Intergovernmental Group on Tea, and he is the co-chair of Organic Tea and Climate Change Working Groups as a member of the International Society of Organic Agricultural Research. He also is the co-chair of the Climate Change Working Group of FAO Intergovernmental Group on Tea since 2014. He is the co-chair of the Organic Tea Working Group, FAO Intergovernmental Group on Tea since 2012. He is the director of China International Tea Cultural Research Institution since 2014. He also possesses a very impressive research career. He is the recipient of 28 research grants, national and international, and of these, 11 projects have received awards. And the latest is for the project on effects of climate change on tea agroecosystems and development of key technological measures, which received the second prize of Science and Technology Innovation Award by the China Tea Society in 2021. He also is the recipient of many personal awards, including one of the 2000 Outstanding Intellectuals of the 21st Century and Leading Scientists of the World, selected by International Biographical Center. And he has also been listed in the prestigious Marquis Who's Who in the World in 2009, 2013, 2014, 2015, 2016, 2017, 2018, and received the prestigious Albert Nelson Marquis Lifetime Achievement Award in 2018. He also has more than 230 peer-reviewed publications to his credit, out of which more than 45 are in SCI indexed journals and about 80 in peer-reviewed Chinese core journals. He has authored 31 peer-reviewed book chapters, and he has edited 19 books. At present, he also serves as the associate editor, Frontiers in Plant Sciences, in the section of plant metabolism and chemodiversity since 2020. And he also is a member of the editorial board in the Journal of China Tea Science since 2018. He also has 12 patents to his credit, and he has been a visiting scholar at Rothamsted Research in the UK. And I'm also happy to announce that he also has been a visiting scholar at the Postgraduate Institute of Agriculture here in Sri Lanka in 2005. I'm sure there are many of you who are known to him in the audience. So with that very brief introduction, Professor Han, I warmly invite you to deliver the speech on impact of climate change on tea production and the adaptation strategies.
Ladies and gentlemen, good afternoon. First of all, I'd like to appreciate the organizer, especially the Professor Janiki Mahati, to invite me to participate in this annual Congress. I'm so proud that I was a student of PGIA for 1 year during 1998 to 1999. My supervisor is Professor Han-PGIA. I'm so impressed by the beautiful campus and also the hard-studying student. I have learned a lot during my stay in PGIA. So I appreciate many thanks to the PGIA. Today, my topic is the impact of climate change on tea production and the adaptation strategies. I will present in 4 parts. First, a very brief introduction of climate change. As we know, climate change has been taking place since the Industrial Revolution, and the temperature has already increased by 1.1 degrees since then on the world average. And the climate change will continue, even in great pace. IPCC has predicted that if greenhouse gas is no more increased, the temperature still will increase by 0.6 degrees by the end of this century. But if greenhouse gas is increased with the current letter, the temperature could be increased by 4 to 5 degrees and even more. And the world community want to contain the temperature increase within 1.5 to 2 degrees. And also they just finished the COP26. They want to contain the temperature increase within 1.5 degrees. But it seems it's a very difficult, even impossible task, because IPCC has already predicted that by 2030, the temperature increase could be 1.5 degrees at the end of this century, not century, 2030. So this is very serious problem. This is a general situation. And how about the tea growing areas, the climate change? We select 4 cities in different regions in China to see how climate change taking place. And the result shows in the last 60 years, the temperature was steadily increased, and the annual mean temperature was increased from 1.2 to 1.9 degrees in different cities, and average is 1.6. And it is much higher compared to the world average, because this is only the last 60 years. And the annual precipitation did not change significantly, but the number of rain days reduced by 11 days, and atmospheric relative humidity reduced by 5%. And the monsoon appeared some 22 days later than in 1980. And also the sunshine was reduced by 41 hours annually. I'm not sure why. Probably there's more cloud days And more importantly, the extreme weather events like the high temperature, frost, flooding, and drought are significantly increased. So they significantly affect the tea production and the tea quality. And the tea plays a significant role, not only in China, but also in Sri Lanka as well. So compared to the climate change for the tea sectors, it is essential. In terms of the start of the climate change, the tea is not only a cash crop, but a modern plant for premier crops. Now, this is concluded not me, but by the Professor Colin Orleans. He is a dean in Tufts University. He thinks the tea is a good crop for the start of the climate change because tea is a wide range of distribution and long economic life. Also, it has a stable ecosystem. And especially tea is very rich in the secondary metabolites like the tea polyphenol, amino acids, which are easily changed with the environment. So those secondary metabolites can act as an ideal indicator of the climate change. So in the US, there's no commercial tea garden, but there has a project from the National Science Foundation. So many of work we cooperated. So how climate change will affect the tea production? No, we use like the face can increase the CO2 concentration, and base can increase the temperature and also can regulate precipitation. And the OTC can increase both the CO2 concentration and the temperature. We use those advanced facilities to conduct the research. And with the increase of the temperature, the tea growing area would be extended to high latitudes and high altitude ecosystems. And the most suitable tea growing areas now is expected to decline. For example, in Hangzhou City, now we produce the most famous Chinese green tea, the West Lake Longjing tea. But probably with the climate change in the future, the quality will be declined. This should not be happening. And the duration of the growing and the plucking period will be extended in highland and subtropical areas. We also set up a yield response model using the historic data to estimate the effect of weather factors on tea production. And the results shows precipitation is more important than the temperature. Also, with the increase of the temperature and the CO2 concentrations, the tea yield, the production should be increased to some extent. For example, if we increase the CO2 concentration into 800 ppm, the plant height, climate, root to shot ratio will significantly increase. The yield could be increased by 41% in a pot experiment. Of course, in a field experiment, the yield increase is much less. Our experiment is 11% increase. Of course, the extreme weather events like the heat and cold definitely will affect the tea production. How about tea quality? We have many quality parameters like tea polyphenol, amino acids, caffeine. Those parameters should be balanced. If not balanced, it will deteriorate the tea quality. For example, tea polyphenol, it is a healthful components. It is a good product. But if a tea contains too much polyphenol and low amino acids, and then when we're drinking this tea, we feel very bitter and astringent. So it's not good tea. With the increase of the temperature and the CO2 concentrations, we can see the tea polyphenols will increase, but amino acid will reduce. So it will affect the tea quality, especially the green tea quality. So use the pathway analysis also shows the relatively low temperature, it is beneficial to the nitrogen metabolism, especially the amino acid synthesis. And high temperature, it is beneficial to the catechin metabolism, but it also will disintegrate the nitrogen metabolism. And the related gene express also shows that the CO2 elevation can improve biosynthesis of flavonoids, but decrease of the amino acids. how climate change will affect the tea ecosystem in terms of the greenhouse gases emission. We conduct a lot of research on this in different soils, different production level, different standing age, and also different soil pH levels. And the results show that on the average, there are 27.5 tons of the carbon emitted per hectare annually. Of course, high organic matter, high temperature produce high CO2 concentrations. And those 27.5 tons, about 60% is produced by roots and 40% is produced by basal respiration. And the nitrous oxide emission is depending on a number of factors. Of course, high temperature, high nitrous oxide emission, and also depending on how much nitrogen we applied. If we apply high amount of nitrogen, for example, 900 kilograms per hectare, 3.4% of the applied nitrogen will be produced by nitrous oxide. It is very high. But if we reduce the nitrogen application into 300 kilograms, then 1.4% of applied nitrogen will be emitted as a nitrous oxide. It's not low, but it's not much different with the vegetable soils. And also the nitrous oxide is produced both by nitrification and denitrification, but majority is from the denitrification. So if a soil contains too much of the moisture, at that time, if we broadcast or we apply the nitrogen fertilizer, then the high amount of the nitrous oxide will be produced. So when we broadcast the urea or compound, after rainfall or before rainfall, it is quite different. After rainfall, we apply broadcast the urea, it produces less nitrous oxide. And also the soil pH plays a significant role. In the neutral soils, the final product of the denitrification is nitrogen gas. But in a very acidic soils, the final product of the denitrification is nitrous oxide instead of nitrogen gas. So for very acidic soils, if we can increase the soil pH level, it can reduce the nitrous oxide. In Sri Lanka, I know you apply less nitrogen fertilizer. You also use the downlight to increase the soil pH. I think it's a good practices to reduce the nitrous oxide emission. And also with the CO2 concentration, the plant mineral nutrients will be quite different. In plants, the carbon will be increased, but other mineral elements like the NPK, calcium, sulfur, even zinc or copper, almost all other elements will be reduced. Most of them can be reduced by 80%. Nitrogen can be reduced by even 16%. So in the future, definitely we need to apply more fertilizer to balance the increase of the carbon in plants. Climate change also will increase the pests and the disease. For example, with the increase of the CO2 concentrations, a disease, anthraquinose, it's a typical disease in China. It will be increase its incidence. This is because with the increase of the CO2 concentration, the caffeine concentration in pea plants will be reduced, and the caffeine plays a role for the control of the anthraquinose. So if we spray the caffeine, it can reduce, it can increase jasmonic acid and also the LOX enzyme activities, and finally reduce the incidence of the acronose. And blessed blighter, it is a typical disease in the tropical area. In Sri Lanka, you can see it many ways. But 10 years ago, in China, especially in subtropical areas, we can't see this disease. But now, in Zhejiang, even in Hunan province, we can see it. In some places, that is even a problem now. So it is very difficult to control it. So what can we do? what kind of mitigation and adaptation strategies we need to take? I think we need at least 3 levels. And first is government policy and strategies with the government officials and with the scientists for the research and development, for the new technologies, new tech products, and also need the community levels for the farmers to involvement, and also, of course, the technology extension. Those 3 levels, government, scientists, and the farmers should be integrated and implemented some adaptation measures immediately. Specifically, we need to diversify and improve the tea ecosystem by planting more trees inside or around tea gardens. And also we need to buy an animal husbandry with the tea production. For example, if we're raising pig, it can supply the organic fertilizer. If we're raising chickens and sheep in tea garden, it can kill pests and weeds. Also, for the farmers, they can get additional income. We also need to promote the low carbon farming system, like the organic agriculture, green farming, good agricultural practices, and climate smart tea production. This is a way for the carbon sequestrations. For example, for the organic agriculture, longer under the organic management, the soil organic carbon is high. And also with the organic management, the soil biomass, microbial biomass will increase. So it will increase the soil bio certification. And also we need to improve the field infrastructure, like the soil and water conservation, drainage and irrigation systems, and agroforest systems. This is use the sprinkler irrigation to prevent the frost. It is very efficient. Actually, the field infrastructure is very effective in combating the climate change and also cost effective in long term. But the initial investment is high. So I think the government should take part. And also we need to develop new technologies and new products. For example, new tea cultivars, which has high tolerance to heat, cold, and drought stress, high resistance to pests and disease, and also high nutrient use efficiency. For example, those are TI developed clones, like Longjing 43 is a high nitrogen use efficiency, and TI 108 is a disease resistant, especially for the ankylosing, it is high resistant. And TRI 302, it is high resistant to drought, cold, and disease, and also has a high nitrogen use efficiency. So it is a very good clone. And also we can use the biochar. Biochar is a good soil amendment because it has many, it is a carbon, but it contains many pores and interspace. So it has a high specific surface area. So when we apply it in the soil, it can improve the soil water holding capacity. It can reduce the nitrate leaching and also the nitrous oxide emission and increase the soil pH and soil organic carbon. And finally, it can also increase the yield and the quality. And this product also can to prevent some extreme weathers like high temperature or low temperature. It's a good soil amendment. And the blister steroid BR, it is a new discovered plant hormones. If we use it as a foliar application, it can improve the photosynthesis of the plant and also increase activities of antioxidant enzymes. So the BR can improve the heat and cold stress. And also the melatonin, it is also a regulator, not only exists in the plant, but also the animals and even human beings. if we use the melatonin as a foliar application to tea plants with certain concentrations, it can prove the late spring-cold stress. It is a very good subsistence. We also develop a foliar anti-freezing agent. For example, if we reduce the temperature into -2 degrees, if we use anti-freezing agent, the t-shirts is still glowing, but in the control, the shirt has already damaged. And this is TI developed some new type of the pest control products. For example, the digital color plate, the yellow one can attract the pests, but the red one can deter the nature animals. So this product is an environment-friendly product. And some infochemicals and biopesticide is very efficient. We also need to have some new ideas to turn bane into a burn. For example, the tea green hopper, it is a pest, but we found that the t-shirts, after it was damaged to some degree, it can increase the volatile compounds. So it can improve the tea quality, especially the tea aroma. So it can be used to produce some specialty tea, like the Orange Beauty tea. So in this case, the tea green hopper is not a pest, but a plant. So we can use it. Of course, we need to let the farmers know the technology, let the farmers know the climate change and its impact. It is very important. So extend the mitigation and adaptation measures, especially the indigenous and the community-based adaptation strategies and the new technology. It is important. So we need education, we need training. And sometimes the technology doesn't work, especially for the extreme weather events. So we also need to develop some crop insurance schemes to minimize the risk of the meteorological disaster. For example, in Zhejiang province, we have the late frost insurance in March, in the spring tea season, when the temperature reduced to some degree, so the farmers can automatically to get some compensation. It is also a good way to let the farmers reduce their loss. This is some education. We have the China Weather TV. We have a program about the climate change. This is for the training to this morning. Once the Dr. Wenyan participated our training. And in the last few years, we published 11 books and 50 papers about the climate change, and many of them is in English. So if some of you interested in it, I can send the electric copies. And our work also gets the attention by the Science and Nature, and Science reported our work, how climate change will affect the production and the tea quality. And the Nature reported our work, how we can combat the climate change. And our work also was recommended by the FAO. FAO South Cooperation Project, a new project they called the Global Low Carbon Tea Triangle Cooperation in Tea Value Chain in Kenya, is going to extend our low carbon technology in Kenya. This is some project meeting. That's all. Thank you. Thank you very much.
For that very interesting and insightful speech of yours. It is now the time for the questions. I would like to request our audience to post the questions to Professor Han in the chat box.
Thank you. Thank you very much. Thank you, Professor Janiki Mohadi, Thank you much. Thank you all. I'm very happy to attend this PGI annual Congress. So there's a question now here, is a biochar usage in tea plantation. And actually biochar is a good soil amendment. So when we apply, because I already said that the biochar has a many, is a carbon, but it's produced by high temperature and high pressure. So it is a carbon, organic carbon. It has many pores or interspace, so it has a high specific surface area. So when applied in the soil, it can absorb more water, more nutrients, so it can improve the soil water capacity, and also can return some nutrients like the nitrate or ammonia, even other nutrients. So when apply it can increase the mineral nutrient usage. But when we apply it, it has a high amount. So for example, at least per hectare, at least 15 tons. Normally we need 30 tons of biochar. So it's a cost, because a few years ago it's cheap, but now it's expensive. So, but for one field, if we apply once, it can exist. It can service for, I think, we at least 5 years, because we have applied the biochar 5 years ago, but now it's still high yield, high quality compared compared to the control. So I think it is a good soil amendment, especially it can also is a way to increase the soil carbon, organic carbon. So this is one question. Another question is organic agriculture. Organic practice, how organic practices can combat the climate change. I think organic agriculture is a way for the also is a way produce less greenhouse gases, and also organic agriculture can improve the soil organic matter and soil microbial biomass, and the tea quality, I think, also better, especially the organic agriculture, organic can, in terms of the high temperature or low temperature in organic tea gardens, it has a good resistant. So another question is, thank you. What are impacts of extended growth and plucking period? Thank you, Dr. Wenyan. Now, this is because with the increase of the temperature, I think, increase of the temperature. So in Sri Lanka, you have all along the year you plucking tea, but in China, we only plucking tea from March to September, sometimes October. But if temperature increase, it can extend the growth later. So in Sri Lanka, I think it's probably it's a no effect. But in China, we can increase the plucking time, so the yield could be increased. That's beneficial to increase the production, I think. So another question already, how much of the biochar to be applied to tea? I think to get its benefit, I think I already answered at least 15 tons of biochar per hectare. Normally we need to use 30 tons per hectare. So it's a large amount of the biochar which should apply. But once you needn't apply every year, even 5 years apply, it's good. Probably it can last forever because the biochar it's very difficult to explanation. Many thanks. There's any question? Yeah, Dr. K. Mohati asked the balance between AA and PP, amino acid and T polyphenols in tea, but with CC, caffeine, do you mean the impact of the impact of the impacts you have experienced with green and oolong type of tea? Yes, I think in Sri Lanka, there's I'm not sure, there's no ratio of the polyphenol to amino acids, but for us, for the green tea, there's a parameters of the ratio of polyphenol to amino acids. It's a quality component. It's a quality polyphenol. For the green tea, we need relatively low polyphenol to amino acids. This is just I mentioned. If a tea contains too much polyphenols and relatively low amino acids, so the tea when you drink, it's very bitter. So people, the consumers don't like it. So we need produce the tea relatively low, but not too low, relatively low polyphenol, but high amino acids. For the amino acids, high and better. So that's why in China, we produce a lot of tea cultivar or tea clones, like the white tea or yellow tea. This is a white liver tea. It's still a green tea, but the tea livers is white, or the tea livers is yellow. This kind of tea normally has high amino acids and low polyphenol because the metabolism has changed. The metabolism is beneficial to the nitrogen, but disadvantaged for the carbon metabolism. So those kind of tea, if high amino acids, people like it and also very expensive. But for the caffeine, normally caffeine is very stable in tea plants. It doesn't change with the environment. So those not just depending on the cultivar. We don't control it. But for the amino acids and the polyphenols in cultivation, normally if we can, we just use those practices to increase the amino acids and lower the tea polyphenol. So this is for green tea. For oolong tea, I think I'm not sure. I think it's similar with green tea, but for the black tea, I think high polyphenol it is better. Another question is whether there are considerable difference in quality of tea produced from biochar applied tea plants and conventional teas. I'm not sure there's a considerable difference, but it has a much difference, including the production, also the quality of tea. Because the plants will absorb more nutrients. I think the biochar is good. Definitely, the quality of tea produced by in a field use the biochar, I think it's good. But I'm not sure there's a significant difference. I forgot it. I'm sorry. It is better, but I'm not sure it is significant. The question is how much the cost of the production to produce 1 kilograms of tea in China. It's quite different. It's according which kind of tea we produced. If it is a famous Chinese tea, it's a high cost, but also the price is very high. But if a normal tea, it's very cheaper. If the tea for exportation, I think it's very low. So it is very difficult to answer your question, how much cost. For example, in TRI, we produce the West Lake Longjing tea, for example. Now it is very high because we're plucking for person. And initially, the very high quality of the West Lake Longjing tea in Hangzhou City, for example, for plucking 1 day, we only can make not 1 kilo, but half a kilo of green tea. So it's very costly. But it's very expensive. So the TRI, the most expensive tea is 60,000 for half a kilo. It's very perfect. But for the tea produced for exporting or for the industry, for example, to produce for the extract, it is very cheaper. I can tell you how much, but it's cheaper because when they produced even 10 yuan for 1 kilo, half kilo, they still can get the profit. But sometimes they use all the machines, not by the hand.
Thank you, Professor Han. There's one more question posted in the Q&A. Can we not use directional breathing to overcome the changes in metabolism?
Yes, the final question is key climate change adaptation measures implemented in tea by Chinese tea growing at present. Actually, key climate change adaptation measures. I think there's many. For example, Norway called the ecological tea garden. The ecological tea garden should have the much higher soil conservation, like also planting trees along the tea garden, and some tropical areas are planting trees inside of a tea garden, and also use less chemical fertilizer and chemical pesticides like this. Another question is, can we not use direct bleeding to overcome the changes in metabolism? Direct bleeding to overcome the changes in metabolism. Can we not use direct bleeding to overcome? I'm not sure. I'm sorry.
Okay, I'm sure there are so many questions. The audience has so many questions to ask because it's a very interesting session, Professor Han. Thank you so much. But I think the time does not allow us to continue. I think so. I think it's time to wind up the session. So I would like to wind up this session by thanking Professor Wenyan Han on behalf of the organizing committee of the PGIA Annual Congress. So thank you so much for joining with us and for that very insightful speech of yours, and also for answering the so many questions asked by the members of the audience. And thank you so much, Professor Wenyan Han, for your very timely topic on the impact of climate change on tea productivity and the adaptation strategies. Thank you very much.
Thank you. Thank you. Thank you very much.
Yes. Over to you, Ravini.
Thank you, madam, for your excellent contribution in chairing the session.